As a software engineer, you would typically start solving a problem by understanding the functional requirements and the problem description that domain experts provide to you. After that, you might start abstracting the problem a little bit by creating entities, for instance. These entities can have several properties and attributes. They might have relationships between one another. We might even have restrictions or constraints on the attributes of these entities. A user email, for instance, should always be unique. No duplicates should be allowed. Domain experts can challenge us with more complicated problems than just storing meta information. Perhaps they would like to know the fuel consumption of the user based on certain properties or using certain algorithms. After having a model that you are happy with, you would start translating the problem that you have into a program or a microservice. You would typically start doing so by setting up the development environment, like spinning up the database container, creating the database, creating the tables that you need to store your entities, creating the constraints and the indexes that you might need to filter the entities, and then perhaps you would go to the application layer and create the appropriate encapsulations for your entities. After that, you might create the program API, and you might add the problem constraints to the application layer in order to produce some useful errors. And then you would write the queries that you need to modify and retrieve the entities from the database. And then you would write the controller and the service functions and abstractions that will validate and orchestrate the whole service. And you would keep writing more CRUD functions, and more CRUD functions, and more CRUD functions until your head explodes or until the sprint comes to an end and you still did not start working on the actual complex problem. And if there is a small bug somewhere under this pile of code, you might waste hours or days trying to find it. Surely, there must be a better way to do this. This is why I would like to present to you an open source proof of concept called Lightspeed. Wouldn't it be useful for software engineers to generate all these CRUD operations that always have the same structure? It might help them focus more on the complex problem instead of writing CRUD operations the whole time. But hold on a second, I hear you say. We already have model-driven architecture that kinda does this, right? You create a UML model and you generate a program from that model. You're not wrong. While the idea of model-driven architecture indeed does this, it has some downsides and limitations. You are a little bit limited in the technical options that you have. A lot of these model-driven generators are too coupled to certain technologies, patterns, and standards, and they may significantly restrict your abilities and capabilities as a developer. Imagine trying to create a reactive or an event-driven microservice from these model-driven generators. This is what Lightspeed does differently. The idea is not to restrict the technologies or the architecture to several choices, but to instead let the developer define a service or a program as a template and provide the domain description in a certain well-defined format. The domain description should also be decoupled from any technologies. If I want to have an interactive user interface, for instance, to create a new service instead of a diagram, it should be possible for me to do so. Lightspeed will then produce a new service that contains the infrastructure and the CRUD operations already defined for you. Notice that I emphasize that the generated service is mainly intended to have the service foundations in a maintainable and a readable way for the developer. The developer should still have full ownership over the generated service. They should still be able to work on the code and to expand the code as if they have written the code themselves. It is not the point to replace the developers, but rather to empower them and save them time by generating the boring stuff for them. If we go back to our example, we can generate a domain description in a JSON format that describes our model, and it might even contain some information that the model does not necessarily have. For example, the attributes that can be used to filter the entities. We can now look at the other side of the equation, which is the template. Let's imagine that we are trying to encapsulate the entities in the application layer, and the application is written in Rust. We can define a template using a well-defined templating language, and Lightspeed can generate the encapsulations from the domain description and from the provided template. We can also do the same in the application infrastructure. If we want to define the Docker compose that will spin up the database, for instance, we can define a template, and Lightspeed can generate the infrastructure for us. We can also generate the queries that we need to modify or retrieve the entities from the database by providing the template for the queries. Lightspeed will then use the provided domain description and generate the domain-specific queries. After that, we can inject the generated queries to the application layer where they are needed. And we can keep generating the foundations for the CRUD operations. The controller layer can now also be generated, and it is all originating from the domain-driven description and from the defined template. After that, we can generate the API, and we can keep doing this iteratively and generate the CRUD operations for all the domain entities, all originating from the domain-driven description that we provide along with the template. Sounds pretty convenient, right? And it might save us a lot of time. It would also be nice if we can have the templates implemented in a modular fashion. Like little Legos, we can swap out the templates we have for certain components and technologies and replace them with new ones or with alternatives. Wouldn't that be great for reusability? I am a big fan of this idea because all parties can be satisfied. Developers will be happy because they have the freedom to update or to change the architecture of their programs how they see fit. They do not have to spend 40 years writing the same boilerplate. Instead, they can focus on the complex and challenging problems. Managers will be happy because the team will be able to deliver faster, since they no longer have to spend weeks writing boilerplate. Customers are happy because they get features faster. Everyone wins, right? Not entirely. While creating a templating language for a simple language like Rust is fairly straightforward, creating a universal templating language that we can use for all the different technologies and patterns would be quite challenging, to say the least. Some technologies use totally different patterns to define how they encapsulate objects, for instance. And let's not forget about the full-fledged technologies that support way too many features and patterns. Can we really universalize all of this in one templating language that can be used for all of them? What is life if we don't at least give it a try? And while the proof of concept seems cool and straightforward, it can also have some downsides. Developers would need to write templates for services and keep them up to date, which may not be a fun task. And if the template has a bug somewhere, all the generated services will have the same bug. Furthermore, the generated code follows the rules that are set by the provided template, which can be restricting. Imagine if you would want to have a different function name that follows the ubiquitous language that you use with the domain experts. But perhaps that's the whole point of Lightspeed. We do not want to get rid of the developers, but rather to empower the developers and make their lives easier by providing them with tools and utilities that help them save time and focus on the more complicated tasks. Lightspeed is still a proof of concept in a very early phase. Currently, it can generate Rust services, but there is still some work to do in order to unify and to universalize the templating language and to add more features. We would also like to generate the services more efficiently. It might even be possible in the future to extend the existing services as well by injecting code for new entities.